Hello everyone, welcome to CIE revision. In this video, I'm going to be solving this variant 1, paper 1 from May-June 2024. It's a pure mathematics 1 paper, so let's start working on it. Number 1, part A says, express 3y squared minus 12y minus 15 in the form 3 bracket that. Alright, so we're expressing this in this form, right? So we see that there's a 3 outside the bracket here, so that tells us that we need to factor out 3 from the whole expression. So it's 3y squared minus 4y minus 5. Then we're going to complete the square for this, right? So that's our 3y minus 2 squared minus 5 minus this 2 squared, which gives us 4 inside brackets like that. And that will be 3y minus 2 squared minus 9, right? Then we're going to multiply everything inside the square brackets by 3, right? That will give us 3y minus 2 squared minus 27, right? And that will be our answer for part A, right? Let's move on to part B. Says, hence find the exact solution, meaning we're not simplifying, and hence meaning we might be required to use this answer from the previous question. Find the exact solutions of the equation this is equals to 0. And if we look closely, we can see that there are some similarities between these two equations, and the only difference is that where we have y squared on this first equation, here we have x to the power 4, and where we have y here, we have x squared here. So we might want to say let y be x squared, right? And if we do that, this equation will be 3y squared minus 12y minus 15 is equals to 0, right? And we can see that this is the same as this, right? And expressing it in its completed square form, we get this answer from part A. So we can safely say 3y minus 2 squared minus 27 is equals to 0, right? Taking this minus 27 to the other side, it will be 3y minus 2 squared is equals to 27. Then we divide both sides by 3 to get y minus 2 squared is equals to 9, right? Then you square both sides to get rid of this square, so it will be y minus 2 is equals to plus or minus 3. Then taking this 2 to the other side, y is equals to plus or minus 3 plus 2, giving us y equals 5 or y equals minus 1. But we know that we said y is standing for x squared, so therefore x squared is equals to 5 or minus 1, right? And x is equals to root 5 plus or minus root 5, and we can't exactly say square root of minus 1 at this stage, so our answer will be plus or minus root 5, and that will be our answer for part B. And we're done with number 1. Let's move on to the second question. We're given a sine graph, I think. Yes, it's a sine graph. So the diagram shows two curves. One curve is equation y equals sine x, and the other curve is equation y equals f of x. In order to transform y equals sine x, which is this one, y equals sine x, to y equals f of x, which is this one. They said y equals sine x is first reflected in the x-axis. So we're reflecting this in the x-axis to get something like, let me use a different color to get something like this, right? That's what we get after reflecting this graph in the x-axis, right? Then it says describe fully a sequence of two feather transformations apart from the reflection in the x-axis, two feather transformations which are required, right? If we look at this, the question is just asking us to write transformations from this red graph to this one, to f of x, right? And so to do that, we are going to say, we're going to consider this point and this point to do our calculations, right? And we're also going to consider this point, the origin. And if we look at this, the red graph, which is this one, starts at the origin, and this one, y equals f of x, starts at -2. And that tells me that there was a vertical translation by vector 0, -2, right? Because it went down twice, right? So if I'm to apply this vertical translation only, I'll get this point here, and this point will be, because the original was at -1, so subtracting 2, it will be at -3, right? Those are the points that I would have, right? Meaning, for me to get to -5, if you look, you have the same difference of -2, like here, right? So that means that I first multiplied this graph, the red one, by 3. And if I multiply 1 by 3, I go to 3, minus 1 by 3, I got down to -3, right? Then if I apply a vertical translation of, if I apply a translation by vector 0, 2, this will come down to 1, and this will go down to -5. As we can see here, it's at 1, and this is at -5. I hope I've made that clear. So let me check that again. We are told by the equation that y equals sine x was reflected in the x-axis to give us this red graph that I'm drawing, right? That was the first transformation, and we're being asked to write two further transformations from this red graph to this one, right? And I'm saying, if we look at this point right here, at where the graph cuts the y-axis, for this red graph it cuts at the origin, but for this one it's at -2, and that tells me that there was a translation by vector 0, -2, right? But for these other points, for example this one, it was at -1, so if I'm to apply this, I will be going down to -3, right? -3, and this one will be here, this will be like this, it will be like this, right? But I see that this point here, after the two transformations that the question has asked us to find, it's now at -5, right? And if I look at this, there's a gap of -2, meaning the first transformation was to get this graph to -3. So if I'm to multiply the graph by 3, this one will be 3, will now be at 3, and this bottom point will now be at -3. And if I'm to subtract 2, this one will go down to 1, and this one will go down to -5, right? So what happened here is we had a stretch of vector stretch of vector 3 in the y-axis, right? Then after that we had the translation by this vector, or 2 units downwards, right? So that's the order. Just going to write that. We had a stretch of vector 3 in the y direction, followed by a translation by vector 0 minus 2, or for this last part you can see a translation of 2 units downwards, right? And you get your 4 marks. So it's 2 marks for each transformation named, right? Then part B says find f of x in terms of sine x. We know we got f of x after applying these transformations plus this reflection in the x-axis to this one. So we're going to use this y equals sine x and apply those transformations. Y is equals to sine x. So first we're going to apply the reflection in the x-axis, so that will be a minus, minus sine x. That's the reflection. Then we're going to apply the stretch of vector 3, so we're just multiplying the graph by 3, so that will give us minus 3 sine x. Then we're going to apply the translation by vector 0 minus 2, that will give us y is equals to minus 3 sine x minus 2, like that, and we get our 2 marks. And that's it for number 2. Right? And number 3 here says the coefficient of x to the power 3 in the expansion 3 plus ax to the power 6 is 160. Then it says find the value of constant a, right? So what we're going to do here is we're going to say that we have 3 plus ax to the power 6. So for us to get x to the power 3, we say 6, choose 3, right? Then we put our ax to the power 3, then our 3 to the power 6 minus 3, which is 3, right? So this is giving us, this is supposed to give us a term in x to the power 3. So we get 20 multiplied by 27, then our a to the power 3, a to the power 3. So 6 choose 3 times 3 to the power 3, 3 to the power 3, that's our 27. 6 choose 3, that's our 20, then a to the power 3. And we're being told that the coefficient, right, of x to the power 3, which is this, because this is x to the power 3 and a to the power 3, the coefficient, which is this part, is 160. So we'll go down and see that 27 a to the power 3 20 is equals to 160, right? And if we divide both sides by 20, we will get 8, right? So 27 a to the power 3 is equals to 8. Then we divide both sides by 27, like so. Then a to the power 3 is equals to 8 over 27. Then we introduce this, both sides, a cube root. So a is equals to 2 over 3. Alright? A is equals to 2 over 3. And that's a bit of binomial expansion there. So I'm going to be doing part B and then following questions in the next videos.